C2, Differentiation Example 7. So now a manufacturer wants to make a cylindrical can to hold 400 centimeters cubed of soup. So now we're asked to find the dimensions so that the surface area is as small as possible. So we can find the volume of the cylinder by doing, well, to find the area of the circle, we do pi r squared, and then we times it by the height of the can, which would be h. So we can rearrange this because we know that this is going to be equal to 400 centimeters cubed. So we can rearrange it so that we have h is equal to 400 over pi r squared. Okay. Now, the surface area can be found, well, we need to find the area of the top circle and the area of the bottom circle. So that would be 2 lots of pi r squared. And then we need to find the surface area of the rectangular piece that wraps around the can. So to find this part, so the length of the rectangle, we'd have to find the circumference of the circle. So we could do that by doing 2 pi r and then the width of it would be equal to h, which is the height of the can. So we'd have 2 pi r h. So this is where we're going to use our h equals 400 over pi r squared, because then we can differentiate the surface area with respect to the radius. So if we put in, so we'd still have 2 pi r squared, but then we'd have plus 2 pi r times 400 over pi r squared. Okay, so this r would cancel with one of these r's, and this pi would cancel with that pi. So we would be left with 2 pi r squared plus 800 over r. So we want to find the stationary points of this. So stationary points, because we're wanting to find the minimum surface area, so stationary point will be found at differentiating the area of the can, surface area of the can with respect to the radius. So we can do that. So multiply by the power, which gives us 4 pi. Oh, sorry, we're looking for where that is equal to 0. So we're going to take this 800 over r as 800 times r to the minus 1. So that would be equal to 2 pi r squared plus 800 r to the minus 1. So now we're going to differentiate that. So that would give us dA by dr equal to 4 pi r minus 800 r to the minus 2. So we're wanting to find where this is equal to 0. So I'm going to take my minus 800 r to the minus 2 over to the other side, which would give me 4 pi r equal to 800 over r squared. I'm going to take my r squared to the other side and move my 4 pi down. So that gives me r cubed is equal to 800 over 4 pi, which is the same as 200 over pi. So of course then we'd take the cube root, so r would be equal to the cube root of 200 over pi, and if you put that into your calculator, we end up with 3.99 centimeters for r. Okay, so we need to determine whether this is a maximum or a minimum. So we need to do d2a by dr squared. So d2a by dr squared. So we're differentiating this part again. So we'd be left with 4 pi plus 1600 r to the minus 3. So if we substitute in r equals 3.99, so that'd be 4 pi plus 1600 over 3.99 cubed. Well, of course, everything here is positive, so we end up with d2a by dr squared being greater than 0. So therefore, we have found a minimum surface area. So I need to substitute my r back into my equation for h all the way at the top here to find out what the h of the can is for the minimum, what the height of the can is for the minimum surface area. So that's using h equals 400 over pi r squared. Substituting in r equals 3.99, so that'd be 400 over pi times 3.99 squared. And if you type that into your calculator, you get 7.99 centimeters. So that means for the minimum surface area for a volume of 400 centimeters cubed, we would need a radius equal to 3.99 centimeters, and we would need a height of 7.99 centimeters. So we managed to use differentiation to find the minimum surface area of a can to hold 400 centimeters cubed of soup.